Hi, it's Dia, and welcome back to Spaced Out. The topic for today is dark matter and dark energy. Understanding these topics are very important in the field of astronomy. Dark matter is a material that we cannot see directly or detect by observing electromagnetic radiation. Ordinary matter either emits or absorbs light that makes it possible to observe. However, unlike ordinary matter, light is not one of dark matter's inputs or outputs. From what we've observed, we think that dark matter particles move slower than the speed of light. Because we can't see dark matter directly, we only know it's there through studying its effects. Some effects we can see are stars orbiting around their galaxies faster than they should be, and through observing a phenomenon called gravitational lensing. As we know, gravity bends the path of objects. It also bends the path of light, meaning that a large object can change the image of a light source far away. And that is what's known as gravitational lensing. Cosmologists often observe clusters of galaxies which reside very close to exactly in between Earth and objects far away that are very bright, such as quasars. Quasars are large and remote objects that output a lot of energy. They then study the images of the distant objects and how they are distorted by the gravity of the cluster to determine its size. Once the size of the galaxy cluster is estimated, the outcome is compared to what we can see, visible matter. The rest is therefore dark matter. We believe that normal matter makes up less than 5% of the total mass of the universe, dark matter taking up 27%, leaving the other 68% to dark energy. Now, what is dark energy? Dark energy is an unknown force accredited to the expansion of the universe. There are multiple explanations for dark energy. One theory, constructed by Einstein, is that it's a property of space. The first property he discovered was that it was possible for more space to come into existence. Another version makes the prediction that empty space can make its own energy. Therefore, if more space comes into existence, more energy would appear, causing the universe to expand faster and faster. Another explanation I personally find interesting comes from the quantum theory of matter. In this theory, the empty space we usually think of is full of temporary particles that are always being created and constantly disappearing. However, this theory, when calculated, came out wrong by a lot. Dark matter and dark energy have been a mystery for so long that every day we are closer to discovering more. To learn more about these topics, visit science.nasa.gov, National Geographic, space.com, and many other websites regarding dark matter and dark energy. I hope you learned something new and enjoyed episode 3.